Building off the last video, we're going to move on to HTTP. So we had our 5 layers: the physical, link, network, the transport, which we hit plenty hard last video, and the application. This is where we're at now. We are now on the application layer. That's where the HTTP protocol lives in. All right? Initially, HTTP was made just to pass around HTML, right? What do they have in common? They have that in common: Hypertext Transfer Protocol. HTML stands for Hypertext Markup Language, right? The HT is the common thread there. If you want to check out something just kind of fun, you can go look at info.cern.ch. This was the very, very first web page that was ever made. You can do a little bit of research. It's kind of fun to go see how it all worked. It's not just HTML. It was the magic that was being able to get all of the networking happen together to pass the HTML around. But HTTP doesn't just pass around HTML anymore. HTTP, of course, does still pass around HTML, but it also passes around images. It passes around 4K videos. It passes around MP4s, M4As, etc. Just about any type of digital file you can think of. You go back and take a look at info.cern.ch, which came out in 1991, and imagine passing out a 4K video, which would be many gigabytes large, or when HTTP was standardized that same year in 1991. If they imagined that this was an eventuality, things are very, very different now. So, as mentioned, HTTP is based on TCP, which is part of the transport layer. And even though TCP and IP are used to help the computers find each other, if the request is initiated in HTTP, the computers both need to be able to speak in HTTP. Okay, so a couple highlights about HTTP. HTTP as a protocol is incredibly efficient. Now, I don't want to confuse you here, but TCP, as I mentioned in the last video, is connection-based, unlike UDP, which basically just starts screaming at the other machine. TCP remains connected. It connects and then remains connected until all the data has been sent. HTTP does not have to stay open. So HTTP is only connected when absolutely necessary. Okay, once the request arrives, the machines will disconnect entirely from each other. As soon as the responder is ready, the HTTP connection will reestablish. It'll reestablish across TCP and will send the response. Okay? Second thing here is that HTTP is stateless. And if you've done REST APIs before, the ST at the end of REST stands for stateless. This means there is no dialogue. All right, that means that the machines only know about each other for as long as the connection is open. As soon as the connection closes, everything is completely forgotten. So if they need to talk again for any reason, they have to start completely over again, which is to say it's like the very first conversation. You need to tell me who you are and you need to tell me what you want. So it's not like a phone conversation where you talk and then I remember what you just said and I say something and then you remember what I just said and I remember what I said a minute ago, right? And the conversation flows, and deep into the conversation, I remember what I said a long time ago. And right, we base the conversation off of the entire conversation. That's how dialogue works. If you're talking, you remember the entire conversation and you talk. Stateless means I only know about what you just said right now, and I'm going to respond based on it, and then I'm going to completely forget everything. So the requester gets one thing to say, and the responder gets one thing to say, and then they are totally done talking. It is a very, very good thing for many reasons. It maybe sounds tricky, but this is the way HTTP works. All right, let's draw a diagram here to kind of illustrate how the process is going to work. All right, you got a user, and the user is sitting on their computer, and their computer is connected to the internet through a wireless card or an Ethernet card. It makes no difference. And they type in a website. Let's say they go to udemy.com. And the user is going to go through their internet connection, and that's going to go through their ISP, and they're going to bounce around however many times, it doesn't matter, and eventually via TCP IP eventually get to the host machine, right? The server, Udemy's servers. And they will go through the process of establishing a connection through that three-way process, where the first thing will be TCP will say, hey, I'd like to make a connection. So this is step one. And via TCP, the server will respond and say, yeah, I'm okay with that, right? That's step two. And then the data will start to come, which is going to be step three. Part of that data is going to be the HTTP request. So the HTTP request will come in to the server. So the request has hit. As soon as that happens, that connection is terminated. Now the TCP connection is still open, but the HTTP request has terminated. Don't worry about how it works. The HTTP is just trying to be efficient. Now the client computer is still patiently waiting for some kind of response because it still wants an HTTP response. While the server's doing its song and dance, it will get an HTTP response together. It will send back the response. That connection will close, and then the TCP connection will close, and then all of this will go away, and everyone can have a nice day. Okay? So that's the basic gist of how the networking will interact and how the HTTP messages will go back and forth. Okay, what does an HTTP message actually look like? Well, there are three pieces to it. An HTTP message has at the top, it has a start line. It's a very descriptive name. It really is just called the start line. It will have a header, and it will have a body. Okay, and HTTP messages are usually just all text, and which is to say you can usually read an HTTP message. I will give you a couple examples later on. All right, the start line is a single line, so it's very, very simple. And it describes the type of request on the way there and on the way back. In the response, it is the status. So it's going to be the method, which let's say it is a get method, followed by the path. Let's say you're getting just the homepage / or let's say you're getting /blog. And then it will be the protocol used, so it'll be HTTP /1.1. Okay? It'll be the version of HTTP that you're using. On the return path, so this is what the request might look like. The response might look something like this. HTTP would come at the beginning 1.1, and then it would give you the status code that you got back. So that might be the 404, which nobody ever wants to get. It might be a 200. It might be a 500. And so on. You get the idea. So that's what the start line is going to look like. That's always going to be the first line of the HTTP message. Okay, whether it's the response or the request. All right, the header specifies the request or describes the body. So essentially what it contains is metadata. And it always comes in the form of key value pairs. So as a JavaScript developer, it'll look like an object, right? A property on the left and a value on the right. There are loads of options in there. The one that we will use the earliest is going to be a MIME type. So you'll see something like content-type : and then maybe you will have text/HTML. Okay? This is a little funny, but worth noting. There's always a blank line right here between the header and the body, and that is to indicate that all of the header is done and that it's time for the body. And the body is going to be the actual stuff. So what you think of as maybe the content, the HTML, right? Maybe it's the content that is the image. Maybe it's binary data or something like that. Okay, so that is what actually makes up an HTTP message. HTTP messages you have to follow this protocol, and it has to be understandable on the other end. Just to bring it home, I'll give you a quick example here. We can use curl, which stands for CURL. It's a really old Linux utility that allows you to make requests and there is a -v option, which stands for verbose, and then we can hand it any URL. I will hand it google.com because Google is a relatively small payload. So I'm going to hit enter. We get a ton of gibberish back. Now this is actually just HTML and JavaScript right here. This is the body. I'm going to scroll up until we get to the top of the body, and here we are. Okay, so this was my initial request here, this top line. Okay, this is some notes that curl is giving us. This isn't actually part of the request or the HTTP message. This is just stuff that curl's letting us know, hey, the URL, you gave me www.google.com. I'm just adding a slash to the end of it. This, just some other networking stuff, doesn't matter. This is the actual start of the HTTP message, okay? This is the start line, right? Get. I made a get request. What path did I want? I wanted slash, right? The home page. This is the protocol, HTTP/1.1. That's the version of HTTP that we're using. For the header here, we have a key value pair, a host, and a value. We have a key value pair here, a user agent, and a value of curl, right? As opposed to Mozilla or Chrome or something like that. The user agent that's actually making the request is curl. We have accept, right? This is, again, a key value pair, */*. Google's willing to accept requests from anywhere. Okay, this is our blank line letting us know that, hey, all right, this was the start line. This is the header. The blank line, I'm all done, and now everything else begins. Now, in our request, we didn't actually send a body because it's a GET request. So this actually signals the end. That's what these arrows here are for. The forward, this arrow is pointing to the right. That's the request. It switches over to a left arrow, meaning this is the response. So this is the first line, the start line, HTTP/1.1, right? 200, and it actually throws in here OK to let us know that that's the response we got. What it actually stands for. And then it starts the headers, a whole bunch of headers, key value pairs. You can look through those. Key on the left, value on the right, just like a JavaScript object. And then we have the blank line here, and then the body actually starts. This is all the HTML and the JavaScript. It's just minified in the case of Google. All right, I'm going to clear this out, and I'll run the same thing again, but I'm going to put in here a bogus path. Okay. This is just, again, information relative to curl. We have the same thing here, right? This is the outgoing message. Get. You try to get this path. Here's the protocol. We have the header. Okay, this is the empty line, meaning the header's all done. We don't send a body. This is the response, the start line. The header, right? This is, right, the 404. We got a different status code. The body we got back was Google letting us, right, know this is the HTML. This is their 404 page. Okay? So this is actually what an HTTP message looks like across the wire. Again, it's most of the time going to be text, something that you can actually read. This is a very simple explanation of how it works, but we're going to be talking about HTTP a lot, and this is what an HTTP message looks like. I've kind of shown you how the handshake works, so the HTTP message, how it gets sent across the wire. Feel free to dig some more, do some research. This is really fun stuff, and feel free, of course, to ask more questions. This is the kind of thing that, as I mentioned, before, you don't need to know it in order to be able to do your job, but the difference between just being a developer and being a great developer is knowing why and how things work that you actually do. So great job sticking to the end of the video for some kind of new and more challenging stuff. We will see you there.